Hi guys, in this tutorial I'm going to solve question number 2, Mechanics 1, Jan 2019 Edex syllabus. At time t0, bird A leaves its nest that is located at the point with position vector 20i minus 17j. This is R0, the initial position, and flies with a constant velocity. This is the velocity v. At the same time, a second bird B leaves its nest, which is located at the point with position vector. This is R0 for the second one, and flies with a constant velocity, pi plus 2pj meter per second, where p is a constant. At time t equals 4, bird B is southwest of the bird A. Find the direction of motion of A, giving your answer as a bearing of to the nearest degree. It's given the velocity of A. Velocity of A is equal negative 6i plus 7j. To show the direction as a bearing, we start from this point, move with velocity negative 6. So this is the direction of negative 6, then 7. So you can find the measure of this angle to show the direction. First, you can find the angle theta. Opposite is 7, adjacent is 6, then add 270. So the bearing as a direction is equal to 270 plus 10 minus 1 for 7 over 6. Or you can find this angle first, then add it to 270. 10 minus 1, 7 over 6 is equal to 49. To the nearest degree will be 49. It's 49.398, and 270 plus 270, so the final answer will be 319. 319. This is the bearing of A. Find the speed of B. Let's now to show the direction of A and B. If we start to show X, Y, for particle A, for bird A, start with initial position 20i and minus 17. Let's say at this point, R0, 20i and minus 17j. And move in this direction. It's given. At the same time, a second bird leaves its nest and flies with constant velocity. At time 4, bird B is southwest of bird A. So I will try now to get the position of each after 4 seconds. Let's start now with with A. R is equal to R0 plus VT. The initial position is given 20i minus 17j plus 4 times velocity, which is also given minus 6i and 7j. You can simplify 20i minus 17j minus 24i plus 28j. So the final position of A is 20i minus 24 is minus 4i, minus 17j and 28 is equal to 3 and 8 is 11j. This is the final position after 4 seconds. By the same way for bird B, R is equal to R0 plus VT. So R of B is R0, the initial position is -8 and 9, -8I and 9J, plus T is 4. Velocity of B is given in terms of P, Pi and 2Pj. Pi and 2Pj. You can simplify your answer and write it in terms of B. -8I plus 9J plus 4Pi plus 2 by 4 is 8Pj. Simplify, RB is -8I and 4P. For J, 9 plus 8P in direction of J. To get the vector RBA is R of A minus R of B. R of A is -8 minus 4I minus 4I and 11J minus R of B minus 8 plus 4Pi minus 9 plus 8Pj. Simplify to get I and to get J. -4 minus will be plus 8, then -4P. For J, 11 minus 9 minus 8P. Simplify more, will be 4 minus 4Pi and 2 minus 8P in terms of J. It's given information when A at this position, B is southwest. So the ratio -1 to 1. So this direction is parallel to -I and J. So parallel means same ratio. So X over X and Y over Y. So 4 minus 4P divided by -1 is 2 minus 8P divided by 1. Use cross multiplication. 4 minus 4P is equal to 2 minus 8P. Solve this equation. 4P is equal to -2. So P is equal to -half. After finding the value of P, you can now find the velocity of B, which is given up in terms of P. Velocity of P, velocity of B, remove P and write -0.5, -2 times half, which is 1. This is I and this is J. Ask to get the speed means find the magnitude of this speed. Velocity of B is equal to negative half I and 1J. To get the magnitude of this velocity, square root of 0.5 squared and -1 squared. And you can use your calculator to get the value 0.5 squared and 1 squared. So the answer will be 1.118. So the final answer rounded. You can keep it exact, which is √5/2, or you can write it 3 significant figure will be 1.12. meter per second. This is the magnitude of the velocity. That's